Hello, everyone. This is Sharon here at HeadSpin. Welcome to today's webinar, Optimize Performance of E-commerce Apps with Automated Regression Testing. We're very excited to have you joining us today. Pretty soon, I'll be introducing Anav. I'm so sorry about that. There was just a weird technical issue for a second. As I was saying, I will soon be introducing Anav Batra, a sales engineer here at HeadSpin. But first, for those who are new to HeadSpin or joining us for the first time, I want to share a quick intro on who we are and what we do. HeadSpin is a digital experience AI platform that combines cloud-hosted and on-prem global device infrastructure, test automation, and ML-driven performance and quality of experience analytics for mobile, web, audio, and video. Our platform empowers engineering, QA, operations, and product teams to assure optimal digital experiences for their users. We're proud to have a global device infrastructure of thousands of devices in more than 100 locations worldwide, running on real carriers and networks. Our mission is to help every company deliver great digital experiences in this ever-evolving and complex digital world. And we've done so for companies across industries and verticals, including retail, which is the topic of today's webinar. And before we get into things, I wanted to relay a few housekeeping items. We want this webinar to be interactive. So if you have any questions, please feel free to drop them in the chat box below, and we'll get to them in our Q&A at the very end. This session will also be recorded and sent to all attendees afterwards, so don't worry if you miss anything. And you can always find our webinars on our website as well under the webinar tab. All right, let's go ahead and get started. Here is Anav.
Hello everyone, my name is Anav Batra. I'm part of the sales engineering team here at HeadSpin. I've been part of HeadSpin for more than a year now. I'm the point of contact when we first engage with the client and the technical lead on the proof of concepts. I work to provide technical solutions to more than 30 of our customers, and I work with all the e-commerce customers as well. One of the main issues our e-commerce clients have tried to address recently is shopping cart abandonment. So in this webinar, I'm going to go over how HeadSpin company helps to solve this problem. So what is shopping cart abandonment? Shopping cart abandonment is when a potential customer starts a checkout process for an online order, but drops out of the process before completing the purchase. Any item that enters the shopping cart but never makes it through the transaction is considered to be abandoned by the shopper. Shopping cart abandonment is a problem for businesses since they lose around $18 billion in sales revenue each year. One of the main reasons for shopping cart abandonment are issues with user experience. Poor mobile experience leads to unhappy customers since customer expectations are not met. According to industry research, around 7.57% of shoppers will abandon an app if the load time lasts longer than 3 seconds. That's roughly about $1.36 billion in lost revenue each year. 40% of customers expect mobile apps to load in less than 3 seconds, and 75% will abandon it and go elsewhere if the app is slow, buggy, or prone to crashes. Furthermore, nearly a third of the consumers will not use a mobile app again if it does not work the first time. So, therefore, reducing shopping cart abandonment often leads to an increase in sales revenue for all the companies. Amazon says that for every 100 milliseconds of latency, their costs increase by 1% in sales. Pinterest says that rebuilding their pages for performance has led to a 40% decrease in their pinner wait time, which has led to a 15% increase in conversion rate to sign up. Therefore, a decrease in page load time will lead to an increase in user retention, which will reduce shopping cart abandonment. HeadSpin helps to solve this problem using its Nimble app. So what is Nimble? Nimble is basically testing your app in a controlled environment where the only variable is the change in your code. The device, network, region, and OS are kept constant. So Nimble provides quite precise timing where the only reason and the degradation of app performance is because of the changes in code. In this next part, we're going to cover how Nimble reduced shopping cart abandonment for a customer by highlighting each of these points in more detail in the following slides. So this is a case study we did for an online retailer. Some of the client objectives were to monitor KPIs, report build over build increases in response time, and also identify areas of optimization. We were able to successfully meet the client objectives by identifying degradations in code performance that were impacting the customer user experience. As a result, the user retention for the customer improved by 39% on iOS and 64% on Android. This is the Nimble dashboard. The Nimble dashboard shows all the customer KPIs that were recorded. For this customer, some of the KPIs that were recorded were code startup, load checkout, and load product details. Customers can choose any scenario or KPI that they would deem useful. For example, a travel company will choose KPIs such as searching for a flight, booking a flight, and canceling a flight. Nimble also supports various Android and iOS versions. Often the same code is run on different devices. This can lead to issues because mobile phones supporting different versions would have different mobile performances. For example, an application running fast on iPhone 12 could be super slow on an iPhone 8. The Nimble tool helps to identify these performance issues, as it can identify regressions up to 50 milliseconds. To analyze and identify these regressions further, the user opens the home page of that particular build. This is basically the Nimble homepage for a scenario. For this report, we took load checkout as a scenario. Now, Nimble's homepage records a number of metrics. One of these is the real time. Real time is basically how long the app takes to complete the checkout on a real device. When the real time is calculated by first uploading the app to Nimble. So when the app is uploaded to Nimble, it first gets installed on a physical device. The test then runs 10 times. The way it runs is that it first installs the app on a device, then it uninstalls it, then it reinstalls it again for the second run, then it uninstalls it again, and it does it for a total of 10 times. By running it 10 times, Nimble gets a very accurate timing information. The homepage also highlights the methods that are leading to the slowdown in the application. There are various types of methods that the homepage identifies. One of these is the hung CPU methods. These are methods that cause the UI to be unresponsive. These methods cause the UI to lag and become unresponsive to the user for longer than 32 milliseconds. Another type of method that the Nimble homepage highlights is the hot methods. Hot methods are background methods which do not necessarily hang the UI thread, but do consume a lot of CPU cycles. We will talk about these hot methods and hung CPU methods later on in more detail. Now, if the user is interested in understanding how the app is performing over time, they can do so by opening the Nimble dashboard again. The user can also do a build over build comparison to understand the performance between any two builds. This feature allows users to identify what changes in code led to degradation in code performance between two builds. So to reduce shopping cart abandonment, we did a build over build comparison for the load checkout KPI. We noticed that the real time for the first build is 3.21 seconds. However, when the build was uploaded again, the real time increased to 9.23 seconds. So to understand why the real time between the two builds increased so much, we click on the Show More Detail button, which shows us the methods that led to the slowdown of the application. Now we have more visibility into the methods that are causing the slowdown in the app. We notice that there are like a lot of hot methods. For the build, that took 9.23 seconds. And these hot methods are basically background methods which do not necessarily hang the UI thread, but do consume a lot of CPU cycle. So these methods are taking a lot of the CPU resources, because of which other methods on the UI are not getting enough CPU resources and therefore making the app unresponsive. One such hot method that is taking significant CPU time is the auth-util idle timer.run. We can analyze this method even more further by looking at its call stack. The full call stack displays the methods in the UI thread and the background threads. The methods are ordered as the longest running method followed by the second longest running method. The way it is structured is that method A calls method B and then method C. As you can see, there are 389 calls to current time with this method, and it is consuming almost 3 seconds of CPU time, causing a significant delay to the checkout flow. Rewriting this method will lead to significant improvements in time. Another example of how the full call stack was able to find a slowdown in the checkout scenario for this user. So one of the methods that was for one of the builds that was causing the build to be really slow and unresponsive was the Java class loader get resources as stream method. Now this is a very slow method that was causing the UI to be unresponsive as it was taking around almost 2 seconds to execute. So redesigning this method also significantly improved the low checkout time for the customer. A mobile application is also never really a standalone application. It almost always relies on other third-party vendors as well. The CPU time by SDK shows that the third-party SDKs that the mobile application is using. It is basically a good way to visualize the amount of CPU resources time each of the third-party SDKs is taking in the application. Using the CPU time by SDK feature, the customer was able to identify a SDK-related issue that led to an increase in mobile performance and reduction in shopping cart abandonment. JSON is the most popular JSON parsing library on GitHub. The customer was trying to further optimize the performance of the application and realized that the JSON library is taking more than 5 seconds of CPU time. On further investigation, they realized even though JSON is a popular JSON parsing library, it is the slowest in deserializing Java objects when compared to Moshi and Jackson. So therefore, the customer then started using Jackson library, and this reduced the CPU time from more than 5 seconds to around 3.6 seconds. Besides finding degradation in code performance for the low checkout KPI, the Nimble product was also able to find a number of other issues. For example, the CPU by SDK page identified 4 SDK related issues. The Nimble homepage also showed that although the checkout time was usually in the range of 2.5 to 4 seconds, sometimes a particular build would cause the checkout time to increase to up to 8 seconds. Finally, after using the Nimble product for many months, the performance of the application improved significantly. This slide shows a timeline of how improvements in the app performance led to user retention being improved for the user on iOS and Android over a period of time. By the end of the year, the user retention improved by 39% on iOS and 64% on Android. So this retailer is just one of the many examples of how automated regression testing can significantly improve user retention and reduce the dreaded issue of shopping cart abandonment that so many retailers face. As more consumers are staying in and doing their shopping online this year, it has become even more crucial that retailers prioritize their checkout and overall user experiences. HeadSpin has to solve countless other problems and give retailers a better understanding of how well their app is doing compared to their competitors as well, so they can improve their user experience accordingly. Now I'm going to hand it over back to Sharon.
Thank you, Nav. So with that, we'll kind of go into the Q&A section. We'll start with the ones that came in during the session, but if you have any other ones, please send them over Please send them over in the chat box below. So how are these scenarios that show shopping cart generated?
So all the scenarios are driven by UI tests. With some customers, HeadSpin will write the test as a managed service, while for other customers, we leverage the existing Appium or native tests and provide training or some sort of initial script design and hand it off to the customers.
Great, thank you. Next question. We use Circle CI for iOS builds. Does Nimble integrate with this?
Okay, that's a good question. Yeah, yes. HeadSpin's Nimble product will work with any CI system for Android or iOS, and the integration is as simple as adding a post build task, which basically runs a single command to submit the IPA or APK in the case of Android to Nimble for profiling.
Do you need to add any SDK or make any code changes to my app or to an app, like to my app to use Nimble?
So no, Nimble works with iOS and Android and does not require any code changes to the application. So, however, some of our customers do choose to add some extra logging steps into the native app just to get more precise control of the start and end point of each scenario. But that's basically an optional step and that's not required. And no SDK is required as well for the application.
Great, thank you. And what are the testing frameworks that Nimble supports?
So Nimble supports all the testing frameworks such as XCUI test, Appium, UI Automator for all like both iOS and Android. And also currently the lead developer and maintainer of Appium, Jonathan Lips, is also HeadSpin employee. So Nimble can support any of the um, open source frameworks very easily.
Great, thank you. Let's see if we have any other questions. Oh, and there's one more. How many builds can be uploaded to Nimble in a day?
Okay, so that's a good question. So yes, the customer can basically upload as many builds as they like. Um, Typically, a customer should upload a build to Nimble if code has been pushed. Most of our customers typically upload around 5 to 10 times a day. So there are three things that a customer should know when they're uploading the build to Nimble. To get the nice little Nimble dashboard, customers should always upload using their API token, save email account, and the package name of the application.
Great, thank you. I think that's all the questions we have for today. Before we wrap things up, I just wanted to take a moment to mention that if you or someone you know is looking to get started with automated testing or test automation learning program, HeadSpin University has these free courses available today on its platform. And we're also releasing a course in the next month called Appium and Selenium Fundamentals 2020, which will be all things Appium and Selenium. And like the other courses available, this new course requires little to no prerequisite knowledge. So it's a great opportunity for those who just want to test the test automation waters first. And you also have the option to gain a certification and join a Slack channel where you'll have access to the instructor, Jonathan Lips, and other students as well. So if you'd like to join, just head to ui.headspin.io/university. We also have another webinar coming up later this month about artificial intelligence and machine learning in the QA industry. So be on the lookout for that. All right, that is, I believe, all we have for today. And it looks like we finished ahead of schedule. So we'll hand you back these extra 15 minutes. Thank you all so much for your time today. We hope you found this webinar helpful. I just want to remind you again, the recording will be emailed to you all. And if you have any other questions, we'll be happy to answer them. Just send an email over to anav@headspin.io, or you can leave a note on our webpage as well. Great, have a great rest of the day, everyone. Thank you again.
Thanks so much, guys.
Thank you.